anytime you have a verbal description of some type of product structure or bill of materials, and then you have a question about it, the first thing to do is to draw the product structure diagram. These problems are a good example of that. Let's take a look. Consider the following product structure. Each A consists of 1 B and 3 C's. Each B consists of 1 D, 2 E's, and 5 F's. Each C consists... Wait a minute. Instead of reviewing this data, it's talking about a finished good called A. Each A consists of 1 B, something called a B, and 3 C's. Each B, wait a minute, each B consists of 1 D, a D, 2 E's, and 5 F's. Each C consists of 1 E and 1 F. 1 E and 1 F. How many E's are necessary to produce a single finished good A? All right, now, therein right there lies the question. The product structure diagram itself is a lot easier to work with than the verbal description. Now, the key is anytime that you are asked how many of these do you ultimately need to make one of these, what you want to do is count up the branches. First off, a good check of our diagram is we check all the low-level items here and make sure that they don't themselves have any further children. Like we're not told anything further about a D, an E, or an F. And no, we're not. All right, how many E's? First step, spot the target component. Well, there are E's here, and there's an E here, are necessary to produce a single finished good A. I think of this as multiply up the diagram. You need 2 D's to produce 1 B. So that's 2 times 1 to produce 1 A. So basically we need 2 E's from this direction. You need 1 E to produce 1 C, but you need 3 C's to produce 1 A. So that's 1 times 3 times 1. That is 3 E's, so to speak, from this direction. When we've accounted for them all, whoops, 2 plus 3 equals 5. You need a total of 5 E's to produce 1 finished good A. Now the question after that is highly similar. For practice, you can draw the diagram again, but this is actually the same diagram being described here. Consider the following product structure. Each A consists of 1 B and 3 C's. We have that. Each B consists of 1 D, 2 E's, 5 F's. We've got that. Now wait a minute, the only thing that's different here, each C consists of 1 E and 1 F. How many F's are necessary? That's the only part that's different. It's just asking about a different component. So what I'm going to do is just use the diagram that I sketched before. I'd better switch ink colors so I don't confuse myself. Now I'm after F's. I look at the finished diagram. Here's some F's. Here's a component F. Okay, once I've spotted them all, now multiply up the branches. Over here, 5 times 1 times 1. There are 5 in total coming from that branch. And here, 1 times 3. You need 1 F to produce a C, but you need 3 C's to produce an A. Is again 3 coming from that direction. So in the case of F's, it's 5 plus 3 equals 8. 8 F's, whereas it was only 5 E's.